In a few agentic applications I've worked on, I gave the option to write code to then carry out the task I wanted it to. And I've been a few times now, I've been really surprised and delighted by the cleverness of the code solutions it generated in order to solve various tasks for me. So if you haven't used code execution much, I think you might be surprised and delighted at what this will let your applications do. Let's take a look. Let's take an example of building an application that can input math word problems and solve them for you. So you might create tools to add numbers, subtract numbers, multiply numbers, and divide numbers. And if someone says, please add 13.2 plus 18.9, then it triggers the add tool and then it gets you the right answer. But what if someone now types in, what is the square root of 2? Well, one thing you could do is write a new tool for square root, but then maybe some new thing is needed to carry out exponentiation. And in fact, if you look at the number of buttons on a modern scientific calculator, are you going to create a separate tool for every one of these buttons and the many more things that we would want to do in math calculation? So instead of trying to implement one tool after another, a different approach is to let it write and execute code. To tell the LLM to write code, you might write a prompt like this. Write code to solve the user's query. Return your answer as Python code delimited with execute Python and closing execute Python tags. So given a query like, what is the square root of 2? The LLM might generate output like this. You can then use pattern matching, for example, a regular expression, to look for the start and end execute Python tags and extract the code in between. So here you get these two lines of code shown in the green box. And you can then execute this code for the LLM and get the output, in this case, 1.4142 and so on. Lastly, this numerical answer is then passed back to the LLM and it can write a nicely formatted answer to the original question. There are a few different ways you can carry out the code execution step for the LLM. One is to use Python's exec function. This is a built-in Python function which will execute whatever code you pass in. And this is very powerful for your LLM to be able to write code and get you to execute that code, although there are some security implications, which we'll see later in this video. And then there are also some tools that will let you run the code in a safer sandbox environment. And of course, square root of 2 is a relatively simple example. An LLM can also accurately write code to, for example, do interest calculations and solve much harder math calculations than this. One refinement to this idea, which you sort of saw in our section on reflection, is that if code execution fails, so if for some reason the LLM had generated code that wasn't quite correct, then passing that error message back to the LLM to let it reflect and maybe revise its code and try another 1 or 2 times, that can sometimes also allow it to get a more accurate answer. Now, running arbitrary code that an LLM generates does have a small chance of causing something bad to happen. Recently, one of my team members was using a highly agentic coder and it actually chose to remove star.py within a project directory. So it's actually a raw example. And eventually that agentic coder did apologize. It said, yes, absolutely right. That was an incredibly stupid mistake. I guess I was glad that this agentic coder was really sorry, but had already deleted a bunch of Python files. Unfortunately, the team member had it backed up in the GitHub repo, so there was no real harm done, but it would have been not great if this arbitrary code, which made a mistake of deleting a bunch of files, had been executed without a backup. So the best practice for code execution is to run it inside a sandbox environment. In practice, the risk for any single line of code is not that high. So if I'm being candid, many developers will execute code from an LLM without too much checking. But if you want to be a bit safer, then the best practice is to create a sandbox so that if an LLM generates bad code, there's a lower risk of data loss or leakage of sensitive data and so on. So sandbox environments like Docker or E2B as a lightweight sandbox environment can reduce the risk of arbitrary code being executed in a way that damages your system or your environment. It turns out that code execution is so important that a lot of trainers of LLMs actually do special work to make sure that code execution works well on their applications. But I hope that as you add this as one more tool for you to potentially offer to LLMs, it'll let you make your applications much more powerful. So far, in what we've discussed, you have to create tools and make them available one at a time to your LM. It turns out that many different teams are building similar tools and having to do all this work of building functions and making them available to the LMs. But there is recently a new standard called MCP, Model Context Protocol, that's making it much easier for developers to get access to a huge set of tools for LMs to use. This is a important protocol that more and more teams are using to develop LM-based applications. Let's go learn about MCP in the next video.